Bismillahirrahmanirrahim. My name is Sintakhab Alam, and this was the paper you can watch here of October, November 20, paper 42. It's A levels structured paper. Question number 2 says that state what is meant by the internal energy of the system. So this is again, so it's a format of the question that every first part of the question is mostly knowledge. Simple information is required from you. So you have to just tell me the internal energy of the system. Internal energy, we know that is the total energy, the total kinetic and potential energy of all randomly distributed energies. So we have to add up, we have to take the total of all the kinetic, because it's kinetic energy as well and it's potential energy as well. And they are also randomly distributed in all the gas system, in any system, they're randomly distributed. There is not possible for the system that every particle has equal amount of energy. That's why we always use this word randomly distributed and the sum of all the potential and the kinetic energy. These are the key words to explain the internal energy of the system. Okay, and we have a relation as well to talk about the internal energy. Del U is always equals to Q plus W. This is called the law of thermodynamics as well. We'll be using this as well, where Q is the internal energy, is the energy supplied, and W is the work done. D part says the atoms of an ideal gas occupy the container of volume this, at a pressure this, at a temperature this, and this information is there. So this was all the information in this box, and what is done, then 980 joule of energy is given to the system. What happened? Definitely its volume has increased, its pressure remains same, constant, no change, and the temperature will definitely, there would be the change in the temperature. He is going to ask us about that. The gas is heated in a constant pressure so that the volume becomes this and temperature this. For the fixed mass of the gas, calculate the amount of substance in mole. We have to now calculate the amount of substance in moles. To talk about the amount of substance, we should be very much clear that the amount of substance we can get by the relation PV is equals to nRT. PV is equivalent to nRT. That is the important relation that we can use directly to find the amount of mole, the N. As we have all the information given in the first part, so in this part, we can get the number of moles present into that gas. Pressure is given, volume is given, R is given, and T is also given. So making N the subject of the equation, this gives us PV divided by R and T. Putting the values, the pressure is 2.60 into 10 raised per 5 pascals, and the volume is 2.30 into 10 raised per minus 3 meter cube. R is the universal gas constant, and the value of the R is always given to us in the data booklet, and one can remember this value as well. This is 8.31. 8.31 is the value of the R. While the temperature is 180 Kelvin. So getting it, we can easily calculate the amount of the number of the moles. This is 0.400 moles are here. So we can easily get it as 0.400 moles. Once we get the number of moles in the gas, then he wants us to know the temperature in Kelvin, the temperature T in the Kelvin, which is for the second. So to know the temperature T, We can use different relations for this purpose. All right. We can use the different techniques for this purpose and we can get the temperature T. All right. So we have V, Charles' law is known to us. The volume and the temperatures relation is known to us, that V1 over T1 is always equals to V2 over T2. So this is called the Charles' law. The volume and the temperature are inversely proportional to each other, while the volume and the temperatures are directly proportional to each other while the pressure is kept constant. So that's why they are directly proportional to each other when we just equate them. So it becomes V1 over T1 is equals to V2 over T2. Putting the values, we can easily get the unknown temperature T2, which is equivalent to T over here. So getting the values, the V1 is given to us as 2.30 into 10 raised to minus 3, and T1 is given to us as 180. On the other side, V2 is given to us 3.80 into 10 raised to minus 3, and this is the T which we have to find. So making T the subject of the equation, we can easily get the value of the T. So T would be simply 3.80 into 10 raised to minus 3 multiplied by 180 and divided by 2.30 into 10 raised to minus 3. Getting it and multiplying, we will definitely get the value of the T, which is 297 Kelvin. Simply using your calculator, you can get this value of the temperature. Moving on, in the next part, during the change in B, the thermal energy supplied to the gas is 980 joule. This is the Q given to the system. Determine the work done on the gas during this change. Explain your working. And we have to now talk about the work done on the gas. Normally, the work done on the gas is called W, and this is simply P del V. Pressure and del V helps us to calculate the work done by the gas or on the gas whatsoever. As the pressure is constant and you know there is a change in the volume is there, so getting that, we can get the amount of work done over there. After getting the values, we can decide whether this is positive work done or negative work done. So getting the P is simply constant 2.60 into 10 raised to 5. 2.60 into 10 raised to 5. And the del V, you can say the change in the volume is from 2.6 to 2.3 to 3.8. So putting the gas in as well, but you know the volume has increased. So there is an increase in the volume. So we have to just notice this and we have to get it as well. So there is an increase in the volume from 2.3 to it is 2.30 to 3.80. 2.30 to 3.80, and the 10 raised to minus 3 is common here as well. So finally we get the work done is negative. Multiplying all, we'll get the value, and the value is 390, but this is negative. Okay, whenever it is negative, it says work is done by the gas, 390 joules, but this is negative. So it is very clear this work is done by the gas. So when the work is done by the gas, that is the case, you can write it, work done by the gas. And this is simply whenever it is expanding, so work is done by the gas. And when it is compressed, work is done on the gas. So he then finally asks you to determine the change in the internal energy of the gas. So we can talk about the change in the internal energy. So change in the internal energy is we already have calculated and we know the value is 980 is the value we already given over here, that this is the amount of energy given to the system 980. And this is the work done negative work is done over there. So the del U is simply Q plus W. But here Q is definitely, we have got the value which is 980 joules. But the work done is negative 390. So the total amount of the del U is, subtracting these two, we will get it as 590. So this is the end of the second question.